been a pleasure to be here at such a great audience. Thanks, Dotnetos, señores. Muchas gracias. It's a really amazing conference you tried to do here. So, my name is Łukasz. I'm a founder and CTO at fintech company, and we deal with some data. Sometimes we deal with normal useful data, like one row at a time. Sometimes we deal with a lot of rows at a time. And for some time, also in my previous experience, we've noticed that sometimes it's hard to insert more than one row in a database, especially hundreds of rows or maybe 1,000. And even if it happens not that so often. So today, hopefully it will work. Okay. We'll talk about, is it even a problem? Maybe you only insert 1 or 5 rows to the database always. So if that, then just you can go or maybe listen about some curious edge cases that sometimes you have. Some proposed solutions, and can we actually do bulk update or bulk merge or bulk delete while we're at it? Cool. So what's the fracas, right? Inserting 100 rows to the table or 1,000 should not be a big deal. And as Shai yesterday told, we all hate ORMs, but we love ORMs at the same time because they just be honest, we're lazy. That's why we're programmers most of the time, and also because we don't like to talk to people. Usually, we don't care that much because if it takes long, then it's a database problem, so I'm a developer, so hey dude, I'm doing that. There's an admin problem. Or maybe I don't insert more than 1 row or 2 at all, so this is not even a problem again. And I use Dapper, I don't use ORM, I'm a Dapper guy. Therefore, Dapper makes it amazing. And really, more than 10 rows is data warehousing, so I'm not the right kind of guy to talk to you, right? Maybe 100 rows, right? So, but we are all in a new world. We are all machine learning now. Is your company talking about machine learning? Only a few? Come on, let's admit. I don't believe that. Or maybe IoT. I bet IoT is more popular. Wow. Where are you guys working? I'm not even talking about HFT because that's only like one guy here that's actually working HFT. That's impossible to work outside the US, maybe London. So maybe you had a customer that was really bad. He had 1,000 orders in an AdventureWorks database. And then you had to insert this guy. Possibly took a long time. Or maybe you work with calendars, you know? CTOs have a lot of appointments because they don't work anymore, they do meetings. And if you count the number of meetings during the week, it will be probably in the tens. In the month, it will be hundreds. And you had to CRUD them. I worked in ZocDoc. It's a znany lekarz of the US. And we had to synchronize calendars of doctors. And turns out, you know, when you have 5 doctors at the practice and you have slots that are 15 minutes, in a week or month time, this is almost 1,000 rows per doc. You do IoT. You do Azure Sphere, you know, you measure the temperature in nice intervals, and then suddenly it's like 100 rows to insert from 100 of, you know, those sensors. Or maybe you work in analytics. Generally speaking, you have to calculate something. Possibly some of you work in financial services? Only a few, come on. Where are you guys working? Like, I'm really curious now. Possibly if you work in financial services, you have to insert a lot of rows to DB. I decided to talk about motivational quotes, some famous authors, like, you need to understand one level be what you're doing, Matt Warren, famous author. Shai said ORM is all very complicated. As we all know, this is actually true. If you have ever decompiled EF, it's really
damn complicated. Even link to SQL was pretty damn complicated. And Schechter said, I did not come to Poland to do 20% increase in perf, right? So I have a big KPI at me to increase the perf by more than 20% now. And my own quote, there are only 10 kinds of developers, or 1-0. Those who believe in magic and those who don't. Oh, my slide is fucked up. So some magic examples. You would be amazed how many people believe that array.sort is magic. If I asked you, like, an average developer, explain me how array.sort works for a small table, for a large table, I bet it will not be something that you know, therefore you believe in magic because it works. This is a very magical line. You probably use it a lot. It does a shit ton of work, actually. And that's why it takes so long sometimes. And you believe in magic because you probably did not investigate that much. A small line. It's very magical. Makes things happen or don't happen at with more than one thing. Tick.add. Very magical line, very often used. Sometimes you're surprised that tick.add takes a long time when you insert to a dictionary that's 16,000 size, and it then grows to 32,000. And a thread can break, for example. HTTP client. Do you know that if you create like thousands of them, you will probably break your server? Unless you do some settings, obviously. Or create blob client on Azure. Do you work with Azure at all? More, yes, finally getting some answers. Do you know that this guy has the HTTP client inside him? Therefore, you have to almost work with him as much as with the HTTP client. So magic inside, even more. It's like bling magic. All cloud is actually magic now. Await. This is even magic that I sort of believe because I still don't know all the edge cases that you can fuck it up. And the magic that I sometimes do on my team, ML context, ML.NET, regression trainers like GBM. GBM is gradient boosting machine. This is fucking serious magic. You give him labels on a table and then features, and then it says, oh, this label is this feature. Magic. No ifs, no fors, like what the fuck is it doing underneath? And this is a magic that a lot of business CEOs now believe. And soon they will start to say it's not that cool magic anymore, but it's magic. But I'm also a magic believer. Like yesterday, I learned about gather mask vector 128 and 256, and now I have to understand it more because before it was fucking magic. It's probably even useful for quicksort, possibly also for other things, especially in machine learning and large data handling. Nginx. We do serve a lot of our stuff from Nginx. And actually in my team, I think no one really knows how it works. And I'm CTO, therefore I don't know at all. And this is a really powerful server. It's much more powerful than AIS, to be honest. Kubernetes. Recently, we've migrated to Dockers and shit, and we're doing it in production. And I know something about Kubernetes, like I even read a book, my guys read a book, but really if you talk how does ingress work, or how to set up all those connections within, it's a little bit magic. Therefore, we are all educated engineers, at least most of us. Some of them become engineers during their work, but we are a little bit fairy tale guys. We do like magic. But, to be honest, it's only getting more. Like cloud is actually like a big Merlin thing that hides a shit ton of stuff, and you don't even know how it works. You have to actually ask product group to tell you what the hell is going on and why is it not working. So we are only in the world that gets more and more magical. And I would highly encourage you to really get the one level deeper, just because it's the only part of magic that's left to us to uncover. And that's really interesting, because you don't really want to be the guy just using the API. It's boring. They changed the API, and you have to change it. Maybe they will change you. So what are we talking about? It's not only magic. How to insert data if you want to understand the performance implications of it. Does save changes scale at all? Doesn't matter if the table has cluster index. Do you know what's cluster index? Good. Is really dapper that dapper? Or is it not that much dapper? And Mark Gravel should be more dapper. And a little bit about expansion trees. And I will not talk you what is ORM. I will use some of it. It will not be ORM. I will not talk about SQL. If you don't know SQL, you don't care about SQL, you probably should, just listen for fun of it. We'll not talk about ETL a lot, and multi-threaded JIT, intrinsics, and stuff, no. Maybe just mention. So you inserted the rows, and there are some side effects, right? Let's just say n is 100. Typical junior Łukasz Dziekan writes a code like this because he's all cool. EF, Entity Framework Core, is all rage now. I do a for loop. I save change after every, because I want this guy to be really in, right? As fast as possible. Don't try that at home. Then he's smarter. He says, I'll get outside of the loop. Maybe that's better. What about Dapper? Dapper is a library, for those who have not used it. It's like really a couple of extension methods that work on connection and enable you to just run SQL more fluently, let's just say, like easier, less coding, less boilerplate. So queries insert new person is like insert a record that has first name, last name, and age. I do a parameter here because age is a parameter just to mess up with the query plans. And I also do the same thing. By the way, execute just executes the SQL string. I did some research, and turns out Dapper is really smart. You can actually do enumeration with him. It will do it automatically. So if you do insert new person, you do enumerable range n times, and you do the parameters that are corresponding to the parameters within the query itself. So the age, with the at, it will do the shit for you. Less code, more link, better code, right? Then I got creative. Insert SQL is string builder. Because I'm on a performance conference, I will not concatenate strings, because Kokosa said it's not good for your health. And also your memory. Therefore, I do build a big F string into a big query. Obviously, you will all tell you, this is fucking insecure, whatever, right? This is not SQL parameters. I was lazy. Really, I could do that with SQL parameters. It wouldn't affect that. It's not illustrating the point. So I create a big damn string, and I just execute it. Then I think transactions. On second year or third year, I had transactions. They said, transactions are going to save your ass. So I make a transaction. And we'll discuss in a second. So the only difference between this guy and that guy is that really I put more code around it. Obviously, there has to be some finally rollback, stuff like that, right? But we're talking about the happy path. So I just put more code. So essentially, I bracketed in a transaction. Is it faster? Maybe. Then bulk copy. I was writing some ETLs in my life before. That was an interesting part of my life. I never handled so much data in banks. And turns out there's a class, right? It's old. It's like from 2005 or something. And it's really didn't change much. And it's encapsulating like basically a channel towards the raw data there. I'm saying SQL because it's MS SQL, but really it's not difference in Postgres. There's copy there. You can actually change it a little bit, but it'll work. Oracle has its own shit. It's, I think, Oral bulk something. And MySQL has the same thing. So all of those databases have the same things. The names are different, semantics slightly vary, but actually the mechanism is very similar. Actually, Postgres is slightly more cooler because it has different formats. You can send text. I think you can send binary. So it's like cool stuff there. You can see that this base is being, hammered very, very hard. There are some options we'll touch about. You have timeouts. You have destination table, and batch size means like what size of the batch will be sent to DB in order to write the data to your database. Sometimes it will throw an exception because I didn't initialize how to map those things in the database to the actual object. It doesn't do magic of EF core. You have to do it manually. So then you look at the damn API. It's probably too small, but you then see data table and data row state. How many of you have used these classes since ado.net 2.0? Oh, okay, so then you would know instantly. But then have you ever created a iData reader or implemented yourself? Cool, that's like 3 people. You can do also data row. So that data row is ado.net representation of a row with some really weird methods. Those seem interesting because they look like they could be enabled streaming. And we like streaming. Streaming is no allocation. And then you have to implement it. So you write a class. You think, I'm going to do a little bit Shive's work. I'm going to do some sort of a thing that can translate any object into a table representation, basically, and also make it a data reader, which has a couple of things. Essentially speaking, it translates an enumerable of an object into a class that uses 2 methods: get ordinal, which is the number, essentially like the column number, and a get value, which passes the ordinal value and returns an object. We'll touch that a little bit later because the object is slightly bad. So in order to do that, we have to translate the T data into some kind of stuff, right? You have to write some delegates to handle most of the classes. So Shai showed some expression trees. Turns out they're pretty useful. So we can actually, get a property info. Let's assume we're doing with properties. Some of you might do, public variables. I don't know. I like properties. So we can create like a delegate that will, given the object, will return the value of a said property, right? As you can see, you can order them in an array. So first one returns the first, second returns the second. You can do dictionary, but array is faster. And especially that the object data reader requires it. So this is like, 7 lines of code, and then you can translate any object into a set of funcs that will essentially break it down to single pieces that are being written to database. But then the object means that when we insert ints, doubles, floats, chars, bools, all this shit, will actually be boxed. And I know that. And I'm sad, but I was not comparing it right now to the ultimate solution that would have to actually do emit.il of any types of value types, and you would have to actually implement different interface, because bulk data insert does not use any other method than the one that returns the object. So everything that you do, you can be really crazy Mark Gravel style, but in the end they will call get value int I returns object. So you have to work with it. It's a pull request to the thing. So summarize. We have like 10 types of inserting stuff to database. We have like really basic one. Then we move the save changes downstairs. Then we go Dapper. So essentially speaking, we execute it using some third-party library, row query. Then we make a loop inside the Dapper. Then we wrap it in transaction. Sorry, write a big string, wrap it in transaction, and we do bulk copy. So I have to actually go to my benchmark results. Where is it? Sorry. Oh, yes, cool. So if you look at it, it's probably, maybe I'll do Ctrl plus. Oh, nice. So if I do n single inserts, the n is obviously the number of it. It took 4.7. If I did the loop, so this is Dapper with just, just for and the Dapper. Then I did Dapper makes a loop. It's slightly faster, but it's non-conclusive really with these errors. But then when we put the transaction around it, suddenly things happen. It's faster. Then the insert is like writing this big string. It's slightly faster than normal inserts. And if I do transaction with it as well, it makes it 40% faster. This is just for the benchmarking to show you that I merged out of the benchmark the building of the string, because you can do smart thing that performance guys do, cache it, right? You can cache, potentially pre-compute like 1,000 or 1 million strings allocated in the memory and then just do substrings. But it turns out it doesn't really matter. Entity framework first slightly worse than Dapper. It's not a big deal. It's like, they're doing a pretty good job. And then bulk insert at 10 is not really that much faster. Then I did streaming there. It's slightly faster, but really nothing happens. Bulk insert using data table. So I said, oh, let's do data table instead of this data reader. Slightly faster, but really nothing cares. And then I did this. All I did is change a single option within the database, with the bulk copy, to say, take a table lock. Table lock means that when you do an operation, the whole table is being locked. Write lock, it means nobody else can actually write. And if you have read uncommitted things, you can read, but if you have read committed, you cannot. So it changes the way you compete for resources. And then 8 times faster. But then let's see what happens if we go to 100. Things scale pretty fast. Bulk insert doesn't scale at all. Even those slow guys. Then I did 2,000. It's already 477 milliseconds. And these guys take 15. So this is 20 to 40 times faster. The single most fast way that's not using bulk insert is this large insert with transaction wrapped around it. It's actually still like 7 times slower than those bulk inserts, and by that it's like so slow. Why is that? And couple of maybe things, because there might be some database guys. Shai probably already is like edging, like, dude, like what the hell? What was you where you were inserting? This was an empty table. It had a primary key. It had a clustered index, but it was an empty table. Therefore, the database had, to those who you are interested, had a simple recovery model. It means I cannot go back in time. I cannot, return to how it was a week ago. I could use bulk log. So it was using slightly simpler way of actually logging the things when you insert the database. But if you will be using full logging, it wouldn't be that much of a matter. It will be slower, but not that by much. So you can see that we can actually insert 2,000 rows into database from C#, sometimes this big custom with a lot of them, faster than we can insert 10. That's pretty steep, I think. So why is it? Why is it like that? First thing you need to understand is that why this thing is so much faster. Every insert you do with entity framework, you do with Dapper, whatever, when you execute a query, it's an implicit transaction. The database does it for you. Say begin, tran, commit, unless you have certain flags set on database that say no implicit transactions. Then you would have to commit all transactions yourself. But most of the DBs have it enabled, because otherwise a lot of mess would ensue. I promise you. So you can see that if you're doing multiple operations, please use transactions explicitly, because it gives a huge headache to database, and it actually gives a huge headache to your performance. The other thing is that this thing takes so much time. It's because SQL Server has to parse this fucking query. If you send 2,000 inserts, which is probably like, I don't know, 50 bytes each, this is like 100,000 bytes. Really, though, those guys in SQL Server had to write some guy who like parses it, makes it into tokens, generates 2,000 query plans, actually one per query plan for each, most likely. And it just takes time. On my machine, it takes 60, 45 milliseconds. Obviously, your mileage will vary, but this is non-trivial time to use. So if there was no parse time, that would be much faster. But doesn't actually change this thing. Why is it so much faster still? And it scales sublinearly. The thing is, this is completely different mechanism that you use with one query. It actually opens like a underlying stream directly to the file stream. Obviously, it does it under all guarantees of the database, but essentially speaking, it does not use a lot of infrastructure that SQL.NET Client is using for typical insert. And it tells the database, is like, A, insert it inside, and then commit. However, as you can see, it still takes 16 or 20 more times if you do it by row, because you can tell it to use table lock, which is this guys, and you can use default setting, which is row locks, and it will put the data in row by row. That is actually, as you can see, worth a lot. Obviously, this is not for your typical workload for an OLTP, because I think you don't insert more than 1,000 rows a lot of times, but more for analytical systems or reporting systems, or like for migrations. You have to think about that, because if you don't, you're in serious performance trouble. If you do IoT, obviously now Microsoft tells you, hey, IoT, Azure Cosmos, you know, it's cool and stuff. Stream processing, yes, true. But sometimes you want to store it, especially for pending further analysis. You have to give them to the data scientists. They enable some features, make some predictions, you know, maybe predict some weather. So in the end, those IoT data end up in the DBs more often than we would like to. So when you insert such, you know, batch data into database, think who's using it. Because holding a table log for 1 millisecond is really not a big deal. Unless you're holding it millisecond, then 10 millisecond, then it's a big deal. But if you are holding it for a millisecond for a second, that's like 1%, less than 1% of the time. So that's really cool. Everybody will be glad that you're not taking so much time like here. And usually databases are, you know, shared resource. So you have to be mindful of other users who actually want to select from this guy. Or maybe do an aggregation, maybe do a index rebuilding and stuff like that. So please think about hold logs. This is really great performance advantage that you can take. And know that bulk insert scales amazingly. I have inserted 1 million rows. This is a Intel i7, whatever, 2.6 gigahertz, and this has SSD. And I was able to insert 1 million rows, small rows, under a second. No big deal. And I have a suboptimal setup for DB. I have logs on the same disk as transaction DB, so this is all bad. So really, if you want to scale it, just use bulk insert. All right, so let's go back to presentations. Because we can do so much more. Where is my cursor? Damn it. Cool. So we're past the Jackie Chan guy. We're past the thing. One thing to be mindful is that bulk insert will vary in performance because of what is called minimal logging. Bulk insert will use less logging to the DB if there are certain conditions met. Obviously, you don't have to remember it right now, but generally speaking, it's cool to say if you have an empty table or it has no clustered index and some data and not much other indexes. Because what does it mean minimally logged? If you log, databases are actually, for ACID shit. So you have to log something in order to prevent breakups and being in an inconsistent state. That's the ultimate goal of any relational database, to avoid inconsistent states, because this is really bad. So they can only do those minimal loggings, which does not enable you to go back when things go back under certain conditions, if you are not prepared for it. So minimal logging essentially means that it doesn't count every row and say, okay, it all goes in or all goes out. Generally speaking, most of the databases you will be working with will be fully logged, unless you will be able to do things like, insert all things in the database as fast as possible and then do a merge, or switch partition if it's really large. So it's interesting, but unless you're doing ETL, it's probably not that much of an interest to you. So we built bulk insert. Can we do a batch update or batch delete or batch merge to make it fully EF core thing? It can insert, it can delete, it can update. I don't know if it can measure. It can't, right? So let's do batch insert, right? Batch insert would be like a lot of options. You can be a lazy guy like me, so you make a T, you make an extension method on connection, you can do an extension method on a DB set, you can do an extension method on a DB context, whatever you like. You make some caching, so you figure out what object are you working with. You can use the same POCOs. That's awesome. You can do the same annotations if you like. And then you create like a cache of all the things and the mappings. Because why create the batch insert mappings all the time? You can cache those. Create like a nice cache. This will break if you use it across multiple assemblies within one domain, stuff like that, because it doesn't have domain name. You can actually extend it to use a full type signature if you like. So it will be super proof. But what about batch update? Temp tables. Amazing things. Amazing. You can actually create a temp table with the name and some GUID in order to enable massive processing, because let's just say Łukasz inserts data, and then there's some other guy, another thread inserting data. If they insert to the temp table with the same name, shits can go wrong. Obviously, if we use the temp tables that are connection local, then it's not that big of a deal. But sharing connections sometimes is cool for research purposes, so it's just safer. It's not a big overhead. So you create a command, select top 0 from This is actually the fastest way to create a copy of a table with just a signature. It's no fast, unless something changed in SQL Server. You batch insert to the temp table, and then you write some logic for writing an update query, matching on the keys, and updating the fields you want to. You can do annotations on type to which fields you want to update, or you can update all the fields. It will only affect your I/O. With that, you can batch update 10,000 rows. Much faster way than Dapper and NT-Framework. This is a helper method that batch ID. I just overloaded the object data reader to work with only types of int, short, long, string. So it doesn't allocate stuff. And you can do batch delete. You pass the IDs as a batch insert. You write a query like this. You delete by primary key, and done. Obviously, you can make it even better with having the method signature having a func or a expression, depends on what you value, to actually translate it, an EF core style, into the predicate of inner join. Because maybe deleting by ID is just not enough for you. You could do that. It's done, actually. You can just copy paste from EF, and you can be, batch delete guy. Merge. You guys know what merge is? Cool. Merge is so good in microservices world because it's idempotent. When you insert a guy with the same ID, it will break. When you update, it will not break. But when you insert, it can actually break. And we are in microservices world. Idempotency is becoming cool because things break, messages got delivered twice. So maybe it's safer to actually be protected against that. So you can actually write a merge statement which inserts if it's not there and updates it if it's there. Obviously, it leads to certain dangerous situations if you don't do updates using some timestamps and stuff like that, because the things could get updated again. But most of the time it will be nice. So your mileage may vary. Be careful what you're doing, because this is not safe stuff. But we're not the conference or safe people. We're for performance here. So be careful. But then you can have to write this big query that's just using merge. Which table? So you inserted the data into temporary table. What keys? So you either use the metadata of the database. We actually store a metadata of our database either in FCore, or we just get it from the database itself. They have views with what are the keys, what are the foreign keys, and stuff like that. That's how they do it. And you can do when matched, update, when non-matched, insert. Done. And obviously you cache it, because filling it and allocating it 1 million times doesn't matter. So what is it all about? Please try to reduce your dependence on magic. It's just not healthy. Decompile bulk insert after this comment, if you're interested in. It's really interesting what it does inside, how it works with streaming and not streaming. A lot of things matter in performance. I know you're writing C# code, but the way you write C# code, the way you interact with an external service, in this case is database, as you can see, can impact your mileage a lot. And in the microservices world, when you have a lot of services hosted on one host, where IOs can matter, when blocking certain threads can matter because it can affect other threads, it's really, really hard not to think about it. I know this is probably an edge case for most of you, but I'm pretty sure you insert 1,000 rows at least once a week. So think about it. If it's on your critical path, can it be on your critical path? Is there any chance that you will be executed multiple times per day? Then it's probably worth it. EF Core is really cool. And you know why they didn't do it? Most likely, they didn't talk with them, but it's not typical use case of ORM. But then at the same time, you work in certain use cases with the same data in cases that are bulk and not bulk. And it's just nice from a coding perspective, a conventions perspective, to have it there. So you can write some more extensions and make it even more cool. Bulk insert scales like hell. Just use it. Especially if you use streaming option. Then it allocates very little. You can stream actually gigabytes of data without almost any allocations. The only thing is that this object string boxes stuff, and it's bad, but you can actually write a DB data reader, which is a little bit more complicated, and you can actually work without any object allocation at all. You then have to map all your properties to certain field types, and then it's done. It's not that much harder. Respect the database, please. It's probably one of the best engineered things that happened and you work with. It's really amazing what those things can do. And please do some little bit digging. What types of locks are there? What types of transactions are there? I mean, isolation levels. What keys? How keys work? Is there metadata about database and how actually those ORMs actually extract stuff? Maybe you can use it for yourself. Relational DB can go a long way. We have over 1 billion records in our SQL, and we're not getting done yet. Really, it's not that, oh, I'm billion now, or I'm big data now, you have to go NoSQL. No, like really good partitioned Postgres, MS SQL, all the DBs can actually work really hard for you. And to be honest, we are much more knowledgeable of how to work with relational DBs than NoSQL DBs. They are harder. They hit us in FinAi a lot of times when we were doing Cosmo DBs. You have to completely change the way you actually model your domain or actually access it. Tablock. Reflection. As you can see, reflection can solve a lot of problems as it solves in EF Core. You can solve other problems with it, and it's really not that hard. It's like 9 lines, right? It's really, really cool. And you can actually stream data to SQL Server. So I can actually, maximize your I/O. It's probably the most amazing thing I've seen in a while, that you can actually insert 1 billion records even here, and it's not it's crashing your RAM. That's really cool. And if you do use some more than 1,000 rows or 100 rows, think about it. Maybe just for the coolness perspective. Okay, you can work with it probably with the EF Core and Hibernate or even Dapper, but maybe writing a thing like this just will make you a little bit cooler, for your own satisfaction, and then it will actually bring some performance. Cool. So I have 2 minutes, 30 seconds left. So that's it. Thank you, guys. I hope you learned a little bit.
Thank you very much. Ladies and gentlemen, Łukasz Dziekan. Thank you very much.